Hi students, this is Anita Raj, your chemistry mentor, welcoming you for the second session of lecture on numericals under electrochemistry. In this session, we shall see the problems related to Faraday's first law, second law and Nernst equation, and specifically under Nernst equation, we shall see problems related to EMF of cell, equilibrium constant and electrode potentials. For your reference, I have shared the link of the formulas video in the description box. Do make use of it, students. Well, we shall see the problems one by one now. Read the first problem, students. The amount of energy used in the passage of 2 amperes of current for 100 seconds under a potential of 120 volt is, see in this problem they have given the current in amperes and time in seconds, and also potential is also given, and you are asked to calculate the amount of energy. We shall write the data first. Current, that is I, is given. I is equal to 2 amperes, okay. I, then time in seconds is given, it's given in seconds, okay, 100 seconds, and also potential is also given, right? Potential, it's 120 volts, and you are asked to calculate the energy. How to calculate energy? Energy, that is energy is equal to charge, that is Q, okay, Q into potential, right? What is Q? It is charge, okay. So how to calculate Q? So we do not know Q. Q is not here given in this problem. So see the formula which relates Q with current and time is I into T, okay. When you substitute these two values, it's possible to calculate Q. So what is I? It is 2, is it not? What is the time given? It is 100 seconds, okay. So the charge is 200, okay, 200 coulombs, right? Now we are going to substitute this charge value in this equation, okay. So energy is equal to Q. What is Q? It is 200. What's the potential given? It is 120. So the answer is 24000, okay, and it is in joules. If you want to convert this into kilojoules, we will be dividing this by 1000, so that 24 kilojoules. Understood, students? We shall see the next problem now. Read the problem, students. What current is to be passed for 0.5 seconds for deposition of certain weight of metal which is equal to its electrochemical equivalent? See, in this problem they are asking you to calculate the current, okay. They are asking you to calculate the current I, and what else is given? Time is given. Is it a time is given in seconds, 0.5 seconds, is it not? And one more clue is also given. What is given? It is the weight of the metal is equal to its electrochemical equivalent. Mean that is W is equal to electrochemical equivalent. See here in this problem we shall make use of Faraday's first law. What Faraday's first law states? That is amount of substance getting deposited in an electrode will be proportional to the amount of electric charge passed, okay, that is Q. What is Q? So what Q is nothing but it is I into T, amount of current passed into in amperes into time, okay. So when you are replacing, when you are changing this proportionality sign, you will be including equal to sign and an constant, that is electrochemical equivalent Z, okay, Z into I into T. See, already in the problem it's given that the weight of the metal is equivalent to electrochemical mass. W is equal to Z. See, when you are bringing this W this side, this equation becomes W by Z is equal to I into T. Since this W and Z are equal, when you are dividing this W by Z, the answer will be 1, is it not? So 1 is equal to I into T. What is T? So what is T? What is T? We are in need of I, is it not? T is 0.5 seconds, is it not? So we want I, right? I is equal to 1 by 0.5. So the answer is 2. So what is the unit for current? It is amperes. Understood, student? This is how we should do this problem. We shall see the next one. Read the next problem. When 1.2 amperes of current is passed for 15 minutes through a salt solution, a 0.3565 grams of a metal is deposited on the electrode. The atomic weight of the metal is 96. What is the valency of the metal? See, in this problem they are asking you to calculate the valency. Okay, what else is given? Current in amperes is given, that is I is given, it is 1.2 amperes, and then time in minutes is given, it's not, so 15 minutes, right? So it should be converted to seconds. So whenever you are doing the problem, that should be converted to seconds. And then W is also given, that is W 0.3565, is it not? Then what else is given? Atomic weight is also given, atomic weight. Okay, what is atomic weight given? 96. And you are asked to calculate valency. Okay, they are asking you to calculate valency. So what is the formula? How to calculate valency? See, valency is equal to atomic weight divided by equivalent weight. Okay, atomic weight divided by equivalent weight. Using this formula, it is possible to calculate valency. But see, in this formula, atomic weight, see, atomic weight is there, but we do not know equivalent weight. How to calculate equivalent weight? See, equivalent weight can be calculated using electrochemical equivalent. Z is equal to equivalent weight. We do not know the metal, what the metal is. If the metal is given, it's possible to calculate equivalent weight. So, equivalent weight divided by 96,500. What is 96,500? It is Faraday. Okay, so it is Faraday, right? Okay. Now, so using this formula, it is possible. Using this formula, it's possible to calculate equivalent weight. So now we are going to make use of this value in Faraday's first law. What is Faraday's first law? W is equal to Z into I. We saw in the previous problem, is it not? Z into I. So instead of Z, we are going to make use of this formula. Okay. So write W is equal to equivalent weight divided by 96,500 into I into T, is it not? And we are in need of this equivalent weight, right? So we can reshuffle this formula. So equivalent weight is equal to W into 96,500 divided by I into T. See, we are having all the data, right? So we are going to substitute now. What is the equivalent weight? Equivalent weight is equal to, what is W? It is 0.3565 or into 96,500 divided by, what is I given? It is 1.2 amperes, is it not? And the time is given in 15 minutes. It's given in minutes, is it not? That should be converted to seconds. So how to convert it into seconds? We should multiply with 60. Understood? Now 15 into 60. So now simplify this. What is the answer? So 34,402.25 divided by 1080. Okay, so we'll get, what's the answer? It's 31.85. Okay, now we are going to substitute the equivalent weight value in this in this formula, because we are our intention is to calculate valency, is it not? So already atomic weight is given, and now we have found out the equivalent weight, so easily we can calculate valency. So what is valency? Valency is equal to atomic weight divided by equivalent weight. Atomic weight is 96, equivalent weight 31.85. So the answer is 3. Understood, students? This is how we should calculate the valency using Faraday's first law. A certain current liberated 1.6 grams of oxygen in 1 hour. How many grams of copper can be liberated by the same current flowing for the same time in copper sulfate solution? See here, the data given are amount of oxygen deposited or liberated. It's given, it is 1.6 grams, and the time is also given 1 hour. And they are telling that same current is allowed to pass through another solution for the same time, that is copper sulfate solution, and they are asking you to calculate the amount of copper deposited. Okay, so here we can make use of the Faraday's second law. Okay, we can make use of Faraday's second law. So what is given? Weight of oxygen liberated, is it not? Weight of oxygen liberated is given, that is equal to 1.6 grams, and they are asking you to calculate the weight of copper deposited. Okay, so we can make use of the second law. How to write the second law? It goes like this: weight of copper divided by weight of oxygen is equal to equivalent weight of copper divided by equivalent weight of oxygen. See, for doing this type of problems, you should be aware of the equivalent weight of certain substances, right? So for copper, the equivalent weight of copper is, it's 31.75. Okay, 31.75, and equivalent weight of oxygen is 8. Okay, and now our intention is to calculate weight of copper. Okay, is equal to, divided by, what is the weight of oxygen given? It is 1.6. Now it's easy to calculate the weight of copper, is it not? Simplifying this, you'll be getting 6. When you are simplifying this, you'll be getting 6.36 grams. Okay, so the amount of, or the weight of copper getting deposited is 6.36 grams. Understood, students? Read the problem. Consider a voltaic cell based on these half cells. See, two half cell reactions were given. Ag plus electron gives Ag, and its electrode potential is plus 0.80 volt. Cd2 plus, that is cadmium, plus 2 electrons gives Cd, and its electrode potential is minus 0.40 volt. Identify the anode and give the voltage of this cell under standard conditions. See here, in this problem, electrode potentials were given, and they are asking you to find out which electrode will be acting as the anode, and also they are asking you to calculate the E0 cell, that is the EMF of the cell under standard condition. Okay, so see, actually we all know that which electrode will be used as the anode. The electrode which is having the least electrode potential will be considered as the anode. So when you are taking into account the electrode potentials, the cadmium Cd is having the least electrode potential, minus value, is it not? So this cadmium will be acting as the anode. So the first answer is cadmium. So cadmium acts as anode. Okay, cadmium acts as anode. Since it is having the least reduction potential, that is minus 0.40. Now we are going to calculate the E0 value. E0 cell, electrode EMF of the cell under standard condition is equal to E0 cathode minus E0 anode. Obviously we know this cathode is acting, cadmium is acting as the anode, is it not? So now we can substitute the value. It is an easy problem. So plus 0.80 minus of 0.40. Okay, so the answer is plus 1.20 volt. Understood, students? It's a simple problem. We shall move on to the next one now. Next problem. For the cell reaction, Zn plus 2 Ag plus gives Zn2 plus 2 Ag. E0 cell is 1.56 volt at 298 Kelvin. The value of E cell delta G0 Q at Ag plus and Mg2 plus concentration of 0.001 molar and 0.02 m respectively are. See, in the problem they have given the E0 cell, that is standard electrode potential of the cell. Okay, they have given standard potential of the cell is given, that is 1.6 volt. The temperature is also given 298 Kelvin, and the concentration of the Ag plus ion and Mg2 plus ions are also given, 0.001 m and 0.02 m. Okay, and you are supposed to calculate the E cell value, then standard free energy change, and also Q, that is Q is nothing but it's the mass action ratio. Okay, so all these three data you are going to calculate. So we shall see one by one how to calculate mass action. Okay, we shall calculate mass action Q first. How to calculate mass action Q? Q is equal to concentration of Zn2 plus divided by concentration of Ag plus. See here, we should here we should have the power 2, because here it's given 2, right? 2 Ag plus. Okay, so I'll write down the value. What is the value of zinc? 0.02. Concentration of zinc is 0.02 and divided by concentration of Ag plus ions, it's 0.001 square. Okay, so the answer is 20000. Okay, so the mass action ratio is 20000, right? The second quantity what we are going to calculate is delta G naught, free energy change. Okay, delta G naught. How to calculate delta G naught? See, this is the formula, minus NF E naught. Okay, what is N? It is number of electrons participating, F is Faraday, and E naught is the standard EMF value, okay, of the cell, right? So see, if you are having any doubt in the formulas, please refer to the previous video. I have given the link in the description box. Okay, so now what is N value? How many number of electrons are participating? It's 2 electrons. Is it not 2 electrons are participating, right? So it is 2 minus 2 into what is Faraday? It is 96,500 into E naught value, it is 1.56. Okay, so what is the answer? It is minus 301080 joules. Okay, see, if you want to convert into kilojoules, you should divide it by 1000, right? So minus 301.080 kilojoules. Understood, students? Now we are moving on to the third quantity which we are going to reduce. That is E cell. How to calculate E cell? See, for this we can make use of the Nernst equation. What is Nernst equation? E cell is equal to E naught cell minus 0.0591 divided by N log of this one. Okay, concentration of the product divided by concentration of the reactor. Now we are going to substitute all the values. We are having all the values. E naught cell value is 1.56 minus 0.0591. What is N value? It is 2 log of, what is Q value? It is 20000, right? Now simplify this answer. What is, so when you are simplifying, after finding out, when you are simplifying this, you will get 1.56 minus 0.0295 into what is log of 2000, it is 4.3010. Okay, so finally you will be arriving at the value, it is 1.4 volts. Understood, students? This is how you should make use of the Nernst equation to calculate the EMF of the cell when the EMF E naught value is also it's given, right? Read the next problem. E naught for electrochemical cell Zn, Zn2 plus, its concentration is given 1 molar. Then Cu2 plus, its concentration is also given 1 molar. Cu is 1.10 volt at 25 degrees centigrade. The equilibrium constant for the cell reaction Zn plus Cu2 plus gives Zn2 plus plus, okay, plus Cu will be, see, they are asking you to calculate the equilibrium constant. Okay, they are asking you to calculate equilibrium constant, that is K equilibrium, right? And you are provided with the E naught value, that is 1.10 volt, and also two more things is also given, that is concentration of the solutions, right? So we can easily calculate the equilibrium constant. Let us write the data first. E naught cell, okay, E naught cell value is 1.10 volt, and they are asking you to calculate equilibrium constant. Okay, what is the formula used for calculating the equilibrium constant? K is equal to anti-log of N E naught. N is nothing but number of electrons participating, 0.0591. Understood? So you can make use of this formula, right? So now we can directly substitute the values, because anti-log, what is the number of electrons participating? See here, it is 2 plus, okay, 2 electrons are participating. So 2 into 1.10 divided by 0.0591. Okay, so after simplifying, after finding out the anti-log, the answer would be 1.67 into 10 to the power 37. Understood, students? This is how we should find out the equilibrium constant when the EMF of the cell is given, right? Read the next problem, students. Calculate the EMF of the following concentration cell at 25 degrees centigrade. See, they are asking you to calculate the EMF of the concentration cell, right? So, the cell is also given AgNO3, its concentration is given AgNO3 0.05 m, its concentration also given Ag. See, just to see the beauty of this cell, see, on both the sides we are having the same, right? So, what do you mean by a concentration cell first? So, concentration cells are the galvanic cells which has two equivalent half cells of same composition. See here Ag, same composition, but differing only in the concentration. Only the concentration of the solution is changing, but rather than all the other things are similar. So, these type of cells are called as concentration cells. And you are asked to calculate the EMF of the cell. How to calculate the EMF of the cell? So, the one thing you should always hold in mind that, see, for a concentration cell, always E0 cell will be equal to 0. Okay, this is a very important thing for concentration cells. Okay, this you should have, so that you can easily calculate using Nernst equation. So, what is the formula? So, E cell is equal to E0 cell minus 0.0591 by En log of concentration, that is Q, is not Q, right? So, now using this formula it is easy to calculate. What is E0 cell? 0 minus 0.0591. What is En value? Here it is 1, is it not? For Ag it is 1. 1 log of concentration of 0.01 divided by, what is this? 0.05. Understood? So, when you are simplifying, you will be getting the answer 0.0414 volt. So, this is how we should calculate the EMF of the concentration cell. Understood, students? Fine, students. Hope you might have understood all the problems. I shall meet you all with an interesting core topic within a short period. Until then, it's Anita Raj signing off from you. Thanks for watching.